Indentation fracture toughness of aluminum-graphite composites, influence of nanoparticles. Objective of the study. This study addresses the research gap by systematically investigating how the incorporation of nano-sized graphite particles affect the indentation fracture toughness of aluminum-graphite nanocomposite. The research encompasses the range of experimental and analytical techniques, including particle dispersion and characterization, hardness and indentation, fracture toughness testing, and fractographic analysis. This comprehensive approach aims to shed light on the specific mechanisms through which nano-graphite particles enhances fracture toughness and contribute to the development of advanced composite materials with exceptional fracture toughness. Materials used in the study are matrix material taken as aluminium 6061. Reinforcement material is taken as graphite nanoparticles. Casting method is used ultrasonic assisted stir casting process. The experimentation used is Wicker hardness test. The specimens and the mechanism and the formula is given in the slide. Figure shows the indentation mark with the crack length. We can measure the indentation crack through scanning electron microscopic images, and that will be used to calculate the fracture toughness using the formula which is listed in the previous slide. The main effect plot has been drawn for all the values using Taguchi method. In the figure, it is clearly shows that as the composition increases, the fracture toughness increases, and the load increases, fracture toughness increases. As the holding time increases, the fracture toughness initially it is steady and further decreases. ANOVA analysis shows the composition and the load will affect the fracture toughness more in comparison with the holding time. Spectrographic analysis has been carried out for aluminum graphite nanocomposites. It can be clearly seen that the crack and the deep dimples were present in the spectrographic image. The comparison of micro composites and the nanocomposite has been carried out for the same indentation load and holding time and the same composition. The fracture toughness observed was 9.4 MPa root meter for micro composite, and for nanocomposite it is 20.15. We can clearly see that using nanocomposite the fracture toughness value will be higher for the composite. With the work, we can conclude that it was observed that the fracture toughness of the nanocomposite improved by 30% compared to the unreinforced aluminum alloy. The fracture toughness increased with higher load, indicating that greater load enhances the material's resistance to the crack initiation and propagation. Prolonged holding times may negatively affect the composite's material's fracture toughness, potentially due to the stress relaxation and other time dependent phenomena. The analysis of variance ANOVA identified graphite composition and applied load as a significant factors affecting the fracture toughness. A regression model confirmed that both graphite composition and applied load positively impacted the fracture toughness, while holding time had a minor negative effect. Thank you.